put your phones away. I am now officially ready to get started here. Now that technology has beat me up a little bit tonight. Really started my day out great. Okay, so we're going to talk about atomic structure. That's where we're going to start today. So we have just literally officially shifted out of chapter 2 and 3, and we are hitting chapter 4 and 5. Okay? We'll get to your periodic table very, very shortly here. Okay, so first of all, the atom. The atom has two main parts. Anybody want to venture a guess what those two main parts are? The nucleus and the electron cloud. Okay? Actually, yeah, we're going to go over here and we're just going to break it up like this. I'm going to put electron cloud over here. We'll put some information, and then we're going to put the nucleus right here. Okay. So I'm going to start with the electron cloud. The electron cloud is going to be found outside of the nucleus or around the nucleus. So outside of nucleus. What particle do you think is found inside the electron cloud? The electron cloud. What subatomic particle is found? The electron. Very good. Okay. So electrons, okay, have a negative charge. Electrons are so teeny tiny and small, they say their mass is negligible. Like the mass of an electron or the electrons in the electron cloud, like don't even count towards the mass of the entire atom. Okay? So they're very small. Just to give you an idea, mass of a single electron is 9.1 times 10 to the negative 31st kilograms. That is super duper teeny tiny. Okay? Each electron has a mass 9.1 times 10 to the negative 31st kilograms. Electrons, they're super small, but they're super important. They are involved in chemical bonding. Have you guys heard of ionic bonds, covalent bonds? Have you heard of those in the past? Maybe a little bit? No? Okay. So chemical bonds, these are the attractions that hold atoms together. And it's the electron that is the driving force behind chemical bonding. That's how we get all these chemical compounds. That's how we get sodium chloride. That's how we get H2O, is because atoms are held together with chemical bonds. And those chemical bonds, okay, occur because of the electrons in the electron cloud. Okay. We're going to move over to the nucleus. So, what are the two subatomic particles found inside of the nucleus? What are the two particles found inside of Cheyenne? Protons and neutrons. Let's go ahead and start with the proton. Okay. Proton. Positive, negative, neutral. Which one would you guess? Protons are positive. Found inside of the nucleus. Protons make the atom unique. So make the atom unique. Now let me explain that to you. If the number of protons changes, so does the element. So that number of protons inside of the nucleus really makes the atom it is, or the type of atom it is. Okay? Helium, 2 protons. Iron, 26 protons. Uranium, 92 protons. So that number of protons makes the element unique. It makes the atom the type of element it actually is. Protons have a mass of 1.674 times 10 to the negative 27th kilograms. Now, I'm not going to make you memorize these masses, but I just want you guys to have an idea of, just for comparison, okay? So protons are positive. They make the atom unique, have a mass of 1.674 times 10 to the negative 27th kilograms. Let's see, neutrons. Oops, I know I spelled that wrong. Okay, neutrons. Now, first of all, when I say subatomic particles, I am talking about protons, neutrons, and electrons. Okay? Neutrons have no charge. The number of neutrons can change. And it does not change the type of element. Mass of a neutron is 1.675 times 10 to the negative 27th kilograms. So that just kind of gives you an idea that the mass of a proton and the mass of a neutron are almost identical. Okay? Almost identical. So the nucleus contains most of the mass of an atom. So the nucleus is going to contain majority of the mass of all of the atom. Okay? The electrons are so small that their mass barely even matters. It is the mass of the protons and neutrons that gives us an idea of the mass of a specific atom. Another thing, the number of protons and the number of electrons are always equal. All atoms are electrically neutral. All atoms are electrically neutral, which means, or the reason why they are electrically neutral is because the number of protons, which are positive, always equals the number of electrons, which is negative. Those two always equal. So if I have 6 protons, I'm going to have 6 electrons. If I have 26 protons, I'm going to have 26 electrons. If I know the number of protons in an atom, I automatically know how many electrons there are. The two are always equal. Let me see. I'm trying to decide if there's anything else I want to say before we kind of move on. Electrically neutral, always equal, majority of the mass of the atom. Oh. Let's see. So you have it written down. Anytime I say subatomic particles, I am talking about protons, neutrons, and electrons. So anytime I say, hey, what is the subatomic particle that is found inside of the electron cloud? You're going to tell me what subatomic particle is found in the electron cloud? You would tell me electron. If I said what subatomic particle is positively charged, you would tell me? There we go. Very good, very good. Okay, we're sticking to the board. Trying to keep the video going here. Okay, so can somebody read me that number? 1.00, I think it's 78 something. 794. Okay. So let's talk a little bit about atomic facts and the periodic table. Now I know we've already discussed this before, but this is considered, of course, your elemental symbol or your chemical symbol. Okay. Do you remember us talking about how it's going to be either a capital letter or it could be a capital and lowercase letter? It could come straight from the name, or it could come from which name? Remember, sometimes the symbol doesn't actually match the name of the element. Do you guys remember where it comes from? A different language, yeah, the Latin name. Correct, okay? So, anytime I say chemical symbol, elemental symbol, this is what I'm talking about, okay? Okay, so this guy right here, anybody remember what his name is? Should be on your periodic table. That is the atomic number. And my atomic number tells me what? Does anybody remember? It is sort of. It's definitely helpful. The atomic number is the number of protons in the nucleus. That whole number in the upper left-hand corner, that is the atomic number. That tells us how many protons. If I know how many protons there are, I automatically know how many electrons, right? The two are always equal, correct? Neutrons is a different story, okay? So this atomic number tells me how many protons are in the nucleus. If I know protons, I automatically know electrons. So if hydrogen has one proton, how many electrons does it have? Very good. If oxygen has 8 protons, it's going to have 8 electrons. Lithium has 3 protons, it's going to have. Very good. Okay. So moving on. This guy right here. This guy's got several names to it. This guy is called the atomic weight. This guy is also called average atomic mass. We'll also hear it called average atomic weight. Got a few names, okay? Atomic weight, give you the definition. The weighted average weighted average of all the masses of the naturally occurring isotopes of an element. The weighted average of all of the masses of the naturally occurring isotopes of an element. Now, I'm going to go back and I'm going to define isotopes, and we're going to talk about isotopes in a second. Okay? Atomic weight is actually a weight. It's a mass. It gives us it tells us the approximate mass of one single atom of hydrogen. Okay? So atomic weight is measured in atomic mass units, or AMUs for short. So atoms are super duper tiny. So to just put it on one of our electronic balances and find the mass in grams of an atom or a proton or a neutron, okay, it doesn't make any sense. The gram is a much larger scale than what we would need for measuring really small things like protons, neutrons, or atoms. Okay? So instead of using grams or kilograms or picograms or micrograms, okay, we're going to use a different mass system or a different weighing system, and it's the atomic mass unit. There is a relationship. I could take 1.00794 AMUs and I could convert it to grams. There is a relationship between the two, but there's no need to, okay? If we were to put grams or micrograms on the periodic table, these numbers right here would be in scientific notation and it would be really hard to deal with, okay? So instead, we use a scale that's much, much smaller, okay, and easier to work with when we're finding the mass of super small things. And atoms and protons and neutrons and electrons are super small things. So this weighted average, okay, so one hydrogen atom is approximately 1.00794, we would say AMU, or atomic mass units. Okay, now I want to talk about how we get this number, because it's an average, okay? That goes back to something that we call isotopes. Isotopes, I'm going to go ahead and atoms of the same element with a different number neutrons. Isotopes, these are atoms of the same element with a different number of neutrons. So every element on the periodic table has one or two or three or four, at least two or more isotopes, okay? They're atoms of the same element. The only thing that is different between them is their number of neutrons, how abundant they are, like how popular they are, how often we come in contact with them, and their masses. Let me give you a real quick example here. There are three isotopes of hydrogen. Hydrogen 1, hydrogen 2, and hydrogen 3. Now, a lot of times when we are dealing with isotopes, okay, we have to, sometimes they have specific names, and these guys actually do. Protium, deuterium, and tritium is what their actual names are. But sometimes it's just easier to identify them by what we call their mass number. This whole number right here This guy is called a mass number. And this mass number really does help to identify the isotope, right? Now the mass number is the sum of the protons and neutrons in the nucleus of the isotope. So the mass number tells us the sum of the protons and the neutrons in the mass of that specific isotope. So hydrogen 1, okay, this 1 tells me the sum of the protons and the neutrons in the isotope of hydrogen 1. Now, if I want to figure out how many neutrons are in hydrogen 1, because the thing that makes each of these different from one another is how many neutrons are in their nucleus. And if you have more stuff, it's going to make the isotope heavier. So if you have more neutrons, it's going to be heavier. If you have less neutrons, it's not going to be quite as heavy. So if I want to figure out how many neutrons are in each of these, okay? So the mass number is the sum of the protons and neutrons in the nucleus. Let's see what here. If I want to figure out neutrons will be mass number minus atomic number. That's going to tell me how many neutrons are in the nucleus of an isotope. Now, when it comes to these three isotopes of hydrogen, this guy is super abundant. He's like 99.98% abundant in nature. So this is the one that we find most often in water molecules and in the air and so on and so forth. Okay, this guy, not quite as popular, and this guy is definitely not nearly as popular. So these two are present. We just don't see them very much because they're not super present. It's the hydrogen 1 that is 99.9 something% abundant, and we see all the time, okay? So if I want to figure out how many neutrons are in hydrogen 1, I'm going to subtract my atomic number from the mass number. This guy is the mass number. So what did we decide? What's the atomic number for hydrogen? 1, right? So if I subtract my 1 proton, which is the atomic number, 1 minus 1 is equal to 0 neutrons. So believe it or not, in hydrogen 1, there are no neutrons. That's why it is the lightest element on the periodic table of elements. Okay? It has 1 proton. It has 1 electron, which is not very much. Okay? The mass is super small. So if I subtract my atomic number, which is the proton, 2 minus 1 is 1. Hydrogen 2 has 1 neutron. And if I subtract my 1 proton from hydrogen 3, how many neutrons does it have? It has 2 neutrons. Of those 3, which one is going to be the heaviest isotope? Louder? 3. Hydrogen 3 is going to be the heaviest because it has the most stuff in it, right? It has 2 neutrons and 1 proton. So when it comes to our atomic weight, the weighted average of all of the masses of the naturally occurring isotopes of an element. So this number is an average of each of the isotopes' weights. That's how we get that word average. It's a weighted average, so that means it puts more emphasis on the isotope that's super popular. So the mass of hydrogen 1 is going to be closest to this mass right here, but we're still going to take into account the mass of these two when we're talking about the atomic weight. So the atomic weight is literally, it's a weighted average of all of the elements' isotopes. I got a short video before we move on. I have always heard that you should never compare apples to oranges. So I'm going to start off this lesson by comparing apples to apples. Gosh, what is wrong? Technology sucks. Try this again. I have always heard that you should never compare apples to oranges. So I'm going to start off this lesson by comparing apples to apples. Okay. I still want to talk a little bit about isotopes. Okay, there's several ways that you can write or represent, I should say, isotopes. Just like I did. You can write the symbol, dash, and then the mass number. You could write, just like she did, the name, dash, the mass number. There's one more way that you can write the symbol for an isotope. Isotope symbol, okay? So I'm going to take the symbol for lithium, and right up here at the very top, I'm going to place the mass number, which is 6. And right on the bottom, I'm going to place the atomic number. So what's the atomic number for lithium? The atomic number. 3. So this is another way you're going to see the symbol of an isotope. You'll see the elemental symbol. This number up here is the mass number. This number down here is the atomic number. Now I just want to kind of expand on what she was talking about in regards to the most abundant. So if I was to look at boron 10, boron 11, and boron 12, just like hydrogen, one of these two is most abundant in nature. Okay, as in, remember how hydrogen 1 was 99.9% abundant. Okay, same thing with one of these isotopes of boron. One of them is the most abundant in nature, and the one that is most abundant in nature is going to be the one that is represented on the periodic table. Okay, because we can't just close our eyes and point and say, hey, let's put this guy on the periodic table. We got to decide which one is going to represent or best represents all of the isotopes. So the one that goes on the periodic table is the isotope that is the most abundant. So hydrogen 1, okay, was 99.98% abundant. So that's the one that's represented on the periodic table. So this is how we figure that out. So find boron. Look at the atomic weight and round it to the nearest whole number and tell me what number you get. Louder? You get 11. So that means boron 11 is the most abundant in nature. If you take the atomic weight and if you round it to the nearest whole number, that gives you the mass number of the isotope that is the very most abundant. Okay? I got one more thing we're going to do, and then I'll give you a mass break, and then I'll give you your homework. I'm kind of cutting things out. This guy we will do next time I see you in class, but I'll give you this one. Okay, so I want to practice a little bit here. I can make it bigger. Let me turn it away. Okay. So first of all, anytime I give you a worksheet that's similar to this, okay, just kind of clarify things. Your mass number will either be given to you or you're going to have to calculate the mass number. Okay? You're not going to actually take it off the periodic table. So let's start the first one together. If I know the atomic number is 80, I know the number of protons is 80 as well, right? Okay, so I'm going to fill 80 in right here. I'm going to skip neutrons because there's a little calculation for the neutrons. But if I know I have 80 protons, then how many electrons do I have? Number of neutrons. Now to figure out neutrons, we take the mass number and we subtract the atomic number, right? So the mass number, and we're going to subtract the atomic number from it. So 198 minus 80 is 118? 118. Okay. So let's go over here into isotope names. So look on your periodic table. What element has the atomic number of 80? Mercury. Now we want to mimic this, okay? We're going to put the name of the isotope and attach the mass number, which is 198. And then we're going to come over the isotope symbol. What is the symbol for mercury? Hg. What number goes at the top right here? The mass number or the atomic number? The mass number, which is 198. And our atomic number goes right down here. Okay. If I know it's calcium, look on your periodic table. What's the atomic number for calcium? You can shout it out. 20? If I know the atomic number, I automatically know the number of protons, which would then be 20. We're going to skip over neutrons. That takes a little calculation. Number of electrons is how many? 20. Now mass number, do you remember this number that's attached? This guy is the mass number. So I'm just going to put the mass number right here. We need to figure out neutrons. So we take the mass number and we subtract the atomic number from it. So 42 minus 20 is 22. Thank you. What is the symbol for calcium? Ca. My mass number goes at the top, which is 42, and on the bottom, my atomic number. Atomic number 26. What element is atomic number 26? Iron. I don't know my mass number yet, so I'm going to come back to it. So if I know my atomic number is 26, then I automatically know my protons is 26. And if I know the number of protons, I also know the number of electrons, which is 26. Mass number. Remember the mass number is protons, it's the sum of the protons plus the neutrons, right? So 31 plus 26, for those of you who are good with math in your head, is 57. What's the symbol for, what's the atomic symbol for iron? Fe. My mass number goes on the top. Atomic number goes on the bottom. What number is attached right here? The mass number, which is 57. Very good. Do the last one. Atomic number 19 is which element? Potassium. They give us the mass number, which is 41, so I'm just going to attach him. Atomic number 19, that means protons is. And if I know protons, I automatically know electrons. Now we got to calculate neutrons, so we have to do 41 minus 19. Whoa. Who's going to do that math for me? 41 minus 19 is All of you who are math people in their head? 20 what? 22. What is the symbol for potassium? Right up here. Is that the atomic number or the mass number that goes at the top? Mass number goes at the top, atomic number at the bottom. And then we're good to go. Okay. Let's step outside. Get yourself a mass break.